So hello everyone, welcome to OneClass YouTube channel. My name is Devansh, and today we are going to go through popular calculus questions. So these questions are going to be at let's say high school level, and yeah, maybe possibly at university level also. So if you need any tutoring help, or if you need a one-to-one live sessions, then you can check the links in the description below. And so without wasting your time, let's just start with our lesson today. Yep, so we have we have question number one. I'll start with black color now. So we need to find the derivative of arc tangent x squared using implicit differentiation. So we need to find derivative of tangent inverse of x squared, and yeah, using implicit methods. So what we do is that um, we say tangent inverse of x square, the function, is equal to, let's say, y. Now we take tangent on both the sides, so this will become tangent of tangent inverse of x square equal to tangent of y, and this tangent inverse will vanish, and we'll have tangent of y as x square. um, I'll just read the definition given here. So when using implicit differentiation, y is differentiated as well. The term y prime is multiplied to the derivative of the terms with y. First we rewrite the given equation, recall that. So yeah, now what we do is that we take the derivative of this here. So we take the derivative on both the sides with respect to x, and so this will be derivative of tangent is secant square y. This will be dy by dx, and this will be 2x, and this will be dx by dx. Now I will just divide secant square y on both the sides. So this will become dy by dx is 1 over secant square y, and this will be 2x. So let's just look at the solution given by junior tutorial. So that is arctangent x equal to 1, tangent of 1. Now, then it is secant square y dy by dx is equal to 2x. Then we divide both the sides with secant square y, and dy by dx is 2x over. I'll just write this again. This is 2x over secant square y. So that is the solution for our case. Just a minute. So the solution given here is correct, and I'll just write correct solution. Good work. And solution is correct, so I'll just say that. Now we'll go for question number 2. So this is just a minute, yeah. So this one is question number 2, and it is asking that what are the integrals of inverse trigonometric function. So like there are so many inverse trigonometric function. There are tangent inverse, there is sine inverse, cosine inverse, then there is sine, cosine, cotangent, and there is cosecant inverse and cosine, cosecant, cosine, sine, secant inverse. So there are almost six inverse trigonometric ratios. Uh, we won't be doing for all of them. So integrating inverse trigonometric functions are challenging since it's not as forward as the other integrals. Although we can try to solve this by knowing the derivative of these inverse trigonometric functions and using the method of integration by parts. So in this case, we'll be going for the integral of tangent inverse of x. So we'll find integral of tangent inverse of x dx. So for this, what I will do, first I will write the derivative of tangent inverse x. This is nothing but 1 over 1 plus x square. And now I'm going to do the integration by parts here. So the formula for integration by parts is, suppose we have a function u into v into, let's say, dx. U and v are function of x only. So for going with integration of by parts, what we do is that we take one term and we take it outside. So let's say u, then we write v, and then we write v d. Let's go with um, v dx minus integral of derivative of u times this integral term. So this will be v dx and this will be dx. So here I have assumed that u and v are function of x only. So same kind of approach I'm going to follow with tangent inverse of x. What I will do, I will just write 1 multiplied by tangent inverse of x dx. Now I don't know that whether you know there is a rule of, it is called Eilert rule. So we follow that kind of rule so that we'll be knowing which term should we take as u and which term should we take as v. But what we are going to do is that the integration of we'll just take that term for derivative whose integration is direct integration is not possible. So here the direct integration of tangent inverse x was not possible. So we'll take this tangent inverse of x as u here and this one as v here. So if this is u and this is v, then according to this formula I can say that tangent inverse of x times integral of x dx minus integral of this derivative of tangent inverse of x times integral of x dx, and this whole will be in integration. So again, tangent inverse of x and the integration, okay, I did one mistake here. I did the integration also. This is 1, this will be 1 here, and now the integration of 1 dx is nothing but x. So I'll write this x here minus, now derivative of tangent inverse of x we have already written, so it is 1 over 1 plus x square, 1 over 1 plus x square times this will be again x and dx. Now what I will do, I'll substitute this 1 plus x square, 1 plus x square as, let's say, t. Then my dt will be this will be derivative of this will be 0, this will be 2x dx. I can divide both these sides with 2x. So this will give me the value of dx. So I'll just substitute these values now. So this will be x tangent inverse of x minus integral, and this 1 plus x square is 1 plus x square is t. So this will be t x, and dx will be dt by 2x. I can cancel this x and x. Now I'm going to perform this integration. So integration of 1 over t will be nothing but ln of t, or log natural of t. So this will be x times tangent inverse of x minus ln of half is here t. Remember to always write this as ln, not as log, because people can get confused and write this as log, and if the base of the log is not mentioned log, then it is usually taken as log base 10, and that is not true. So I'll always suggest you that you just take ln, write ln always, and write a magnitude. So write this term which is inside in magnitude, not in brackets, because the correct form is to write this in magnitudes. And now I'm going to substitute the value of t back in this. So this will become x tangent inverse of x minus 1 over 2 ln of 1 plus x square. And yeah, so that is our integration. So integral of tangent inverse of x dx is x tangent inverse of x minus 1 over 2 ln of 1 plus x square. So in this similar way, we can find the integrals of sine inverse, cosine inverse, cosecant, secant, and then cotangent also. So the formula, the final answer are going to be in terms of ln, right? I have a good practice with integration, so I know that this will happen. And let's just check the solution given here. So yeah, so they have followed the same procedure here also. So this is half ln of x plus c. Okay, yeah. So we forgot one c also. As this is indefinite integration, we have to write a constant of integration, which is c. So always remember to write this c. So yeah, so finally they have found that the integral of tangent inverse of x dx is x tangent inverse of x minus half ln of 1 plus x square plus c. Now you can use this method to find to solve for the other integrals of inverse trig functions. So this is pretty much for this question. Like this can be lengthy, but come on, it is calculus. If calculus is not lengthy, then whole mathematics is just like a piece of cake. So this is correct solution given here. Given here, and good solution. Good work. Solution is correct. Okay, so we have, this was question 2, this will be question 3, or and I'll just add one more page. Yep. And this I'll choose for red. Find the derivative of x times mod of x. Does f double prime of 0 exist? So this is question number 3. F of x is x magnitude of x, and f double prime of x we need to calculate. So first I'll just go with this solution only because um, it is a piecewise function. So now f of x is magnitude of x, and this will be equal to so for magnitude terms we have like two conditions. One is that the value inside magnitude is positive, the other one is that value inside the magnitude term is negative. So for magnitude of x we'll have two conditions. If x is greater than 0, then this will magnitude of x will be positive x. If x is less than 0, then magnitude of x will be minus of x. So for this function, one x is also multiplied here. So for x is greater than 0, this will be x square. For x less than 0, this is minus x square, and this will be for negative condition. Now we are going to find the derivative. So for this derivative, what we'll do is that we'll go for um, limits condition. So first we'll go from right hand side and then we'll go from left hand side. So no, first here they are coming from um, this yeah, so they are coming from right hand side and then they are converging from left hand side. So I'll just go with that. So f of 0 from right side is limit x approaching to 0. This will be f of x minus f of 0 over x minus uh, 0. Then this will be this is going to be the first function, which is x square. So this will be limit x approaching to 0, x square over x. This x and x will get cancelled, and this will become limit x approaching to 0 of x. I can just put the value and I will get this as 0. So suppose this is the number line, this is the point 0. So earlier we were coming from here, now we'll go from here. So for f prime of 0 from left hand side, I'll write limit x approaching to 0, again f of x minus f of 0 over x minus 0. This will be f of x now will be minus of x square, so this will be minus of x square. F of 0 will be 0 minus 0, limit x approaching to 0, and then x minus 0, and it will be limit x approaching to 0. This will be minus of x square over x. Again I can cancel this x, and after putting the limit I will get this as minus of 0. It is nothing but 0 only. So both the values are equal, and since f prime of 0 from left and f prime of 0 from right is equal to 0, we say that the function is differentiable at x equal to 0 and f prime of 0 is 0. In the interval of 0 to infinity, sorry, in the interval of this is, yeah, so this is minus infinity to 0, f prime of x is minus 2x, and in the interval of 0 to plus infinity, f prime of x is 2x. So since we know that f prime of 0 is 0, f double prime of 0 will also be 0, like that is true. So if f prime of 0 is 0, Then if we again differentiate this, then again like 0 is a constant. So if the differentiation of constant is 0, so this will be again 0. So the solution given here is correct, and I'll just write correct solution. Good work. Okay, so this will be question number 4. Yeah. So this will be, I'll just go with blue color this time. So this is going to be question number 4. That is, we need to find the integral of 1 over x square minus 9 dx, and we need to use this, we need to find this using partial fraction. So integral of 1 over x square minus 9 dx using partial fraction. Now, so for the partial fraction, what we do is that I'll just take this function. So 1 over x square minus 9. So our goal is to find this, or our goal is to evaluate or find this function in terms of, let's say, 1 over function of x. Uh, this function of x will be in the power of 1, or no, it can power of 2. So 1 over function of x plus 1 over another function of x. So this is the method which we follow for partial fractions, and then we'll just integrate it and it will be ln of f of x, or like that only. So what we do here, um, what we do first, we are going to split this term in terms of single power. So we can clearly see that this, I'll use this. This will be a square minus b square is nothing but a plus b, a minus b. And now what we'll do, we can write this as 1 over x square minus 3 square, and I'll use this identity. So this will become x plus 3, x minus 3. And now I'm going to split this. I'll just write a over x plus 3 plus b over x minus 3. Now the thing is that I don't know what my value of a is going to be and what my value of b is going to be. So what I'll go do is that I'll find the value of a and b. So I'll just add these two fractions. So this will become a times x minus 3 plus b times x plus 3 over x plus 3, x minus 3, and I'll substitute this to 0 so that I can find this, find the value of a and b. So I'll just take the numerator part here. So this will be x minus 3 plus b times x plus 3 is equal to 0. Now for x equal to, let's say, x as 3. For x equal to 3, I can write a times 3 minus 3 plus b times 3 plus 3 is, it will be 1, not 0. It will be 1 here, and this will not, like this will won't be equal to anything. So this will be 1. So this is 0. This is 6b equal to 1. This implies b will be 1 over 6. Now what we'll do is that we'll find for x equal to minus 3. So I'll just substitute x equal to minus 3 in this. So it will become a times minus 3 plus b times minus 3 plus 3 equal to 1. This will be 0 and this will be minus of 6. So this will be minus 6a equal to 1. I'll just divide both the sides with 6, minus 6, sorry. And I will get a as minus of 1 over 6. Now I'll substitute the value of a and b back in this one. So it was minus of 1 over 6. What is happening here? Yep. So minus of 1 over 6 times 1 over x x plus 3. Denominator of a was x plus 3. Yeah. So this is x plus 3 plus 1 over this 6 and 1 multiplied. I'll just rewrite this. So this will be 1 over 6 times 1 over x plus 3 plus, this was minus 1 over 6 times 1 over x minus 3, and I'll take 1 over 6 common. So it will be 1 over x minus 3 minus 1 over x plus 3. Now this was nothing but equal to 1 over x square minus 9. So I'll just substitute the value of this 1 over x minus 9 back into our original differentiation term, or sorry, integral term. So this will be 1 over 6 I can take outside. This will be 1 over x minus 3 minus 1 over x plus 3, and this will be dx. Now I'll do the integration. So I'll use this rule, 1 over x is nothing but dx ln of x. Here you can see that it is not 1 over x, it is 1 over x minus 3, but just to keep it short, so if I say that this is u and this is v, and let's say u is x minus 3 and v is x plus 3, then dx will be du and dx will be again dv here. X minus 3, if we take the differentiation, the dx minus differentiation of constant is 0, so this will, yeah, dx will be du and dx will be dv also. So I can write this as 1 over 6 integral of 1 over u, and this is minus 1 over v. Let's just set this as du. I'll separate the integrals, both the integrals. So 1 over 6 integral of 1 over u du minus integral of 1 over v dv, and this will become 1 over 6 ln of u minus ln of v. Now I'll substitute the value of u and v back in this, so this will become 1 over 6 ln of x minus 3 minus ln of x plus 3. Now what I will do, I'll just use the property of log. So log a minus log b is nothing but log of a by b. So I'll say that 1 over 6, this will be, let's say, x minus 3 as a and x plus 3 as b. So I can write this in 1 log x minus 3 over x plus 3 and a constant of integration. So let us just check this with the solution. So 1 over 6 ln of x minus 3 over ln of x plus 3 plus c. So yeah, the solution given by the junior tutor is correct here. They have followed the same approach. Yeah, so the solution given here is correct, and good job. So this is going to be question number, oh god, fourth was very lengthy. This is going to be question number 5. Question number 5. So it is asking that we need to find the integral of sine square x cosine square x dx by using the identity sine 2x equal to 2 sine x cosine x. So we need to find sine square x times cosine square x dx, and we need to use this identity of sine 2x is 2 sine x cosine x. I'll do this with the red color this time. So what we'll do, this can be written as sine x cosine x whole square dx. Now I will multiply 1 2 here and I will divide 1 2. This whole term is in bracket, and I can use this identity, so I can write in the next step this will be 2 sine x cosine x will be sine 2x, so this will be sine of 2x by 2 whole square dx. So this will become, I'll just take this 2 outside, so this will become 1 over 4 sine square 2x dx. Now I'm going to use the property or the double angle identities of trigonometric. So the double angle identity is cos of 2x is 1 minus 2 times sine square x. With a little bit of manipulation, I can solve this in for sine square x, and it will become, so this will go here, it will become 1 minus cos 2x over 2. So again, I'm going to use this identity in this one. So here we can see that this was in terms of x, but here we have 2x. So I'll just put 2x here and this cos will become 4x. So I was playing with red color. This will be 1 over 4 integral of, this is 1 minus, this will be cos of 4x by 2 and dx. Mm-mm. Yep. So I can just separate the integrals also now because there is one minus sign. So I can write 1 over 4 integral. I can take this 1, this 2 outside, so this will become 8. So 1 over 8, and this will be 1 minus cos 4x dx. Now what I will do, I will do the integration now first. So this will become 1 over 8, 1 dx with x minus cos 4x. So this will become, so let's say this 4x is u. So du will be, differentiation of 4x will be 4. So this will be 4 dx, divide both the sides with 4, and this will be cos of u du by 4. So mm, I'll do this integration. So this was x minus, now integration of cos will be sine. So this will be sine of u over 4, and now I'm going to substitute the value of u. So this is 4, not u. So this is 1 over 8 x minus, this will be sine of 4x over 4, and yeah, 1c for the constant of integration. So I'll just check the solution given here. So they have followed a very lengthy procedure. Final answer is x over 8 minus sine of 4x. Okay, so they haven't multiplied this 8 here. Here their answer was correct. So 1 over 8 minus sine 4x over 4 plus x plus c. But in the final statement, they forgot to multiply this 8 here. So the solution is correct, and I'll just write that the solution is correct. I'll just mention that in the last step the 8 is not multiplied. So the solution is correct only in the final statement. 8 in the denominator, 8 is not multiplied, 8 is not multiplied with 4 in the denominator. Denominator. A. Why this A? Yeah. What the? So 8 is not multiplied with 4 in the denominator of sine 4x term. So I'll just mark this solution as correct because the whole procedure was correct. That was a very lengthy procedure. You can obviously follow this shortcut. And this was question 5. I will go for question number 6. This time I'll start with black color. This is question number 6. I'll just scroll this. Yeah. So we need to find the derivative of square root of x. So d dx of square root of x. Okay, so for this question, what we'll do, we'll use the power rule. So I'll just write the power rule of differentiation. So the power rule of differentiation says that d dx of x power n is n times x power n minus 1. Now, for our case, this square root of x can be written as x power 1 by 2. Now, so it will be pretty much easier because like it is a lot easier and it works well when you just eliminate the square root or cube root or terms and write it in terms of power. So now I will take differentiation of x power 1 by 2, and using this rule I can write. So if so here my n is going to be 1 by 2, so this will be 1 over 2, and this will be x 1 over 2 minus 1 in the power. So this will be 1 over 2 x power, this will be when I take the LCM, so this will be 2, and 2 minus 1 minus 2 plus 1 is minus 1, and this will be minus 1 by 2. Now I can write this as 1 over 2. This power is in minus, so it will be going in the denominator. And yeah, again we can substitute this power in back in terms of square root. So this will be 1 over 2 square root of x. So this is going to be the answer pretty much. Let us cross check with the solution given by Junior Tutor. So using the power rule to find the square root of x. So power rule is d dx. Yeah, so they have gone for the power rule, and okay, so they have done the correct procedure. They have followed the correct procedure and the answer is correct. So I'll just write correct answer. Good work. And like in such kind of questions, we usually like the procedure is just like this, that we convert the square root cube root in terms of power, then we use the power rule of differentiation and we find the final answer, and then we can obviously substitute that power back in terms of square root or cube roots. So we have question number 7. I'll just write question number 7. This question will solve with red color. So this is question number 7. So we need to find the total area of the region bounded by y1 equal to x cube minus 1 and y2 equal to x square plus 3 on the interval of minus 2 to plus 4. So I'll write y1 as x cube minus 1 y2 is x square plus 3, and the interval given here is -2 to 4. Yeah, sorry for that because I was um, yeah. So we have two functions. So in such kind of problems, what we do is that we first check that whether there is an intersection point for the two curves given here. So for the two curves, what we'll do to find the intersection point, we'll just equate these two terms. So we'll just equate y1 equal to y2 for intersection point. We'll just equate y1 equal to y2. This means x cube minus 1 equal to x square plus 3. If I take x cube and if I take x square this side, so this will become x square. This will be equal to, this will be equal to, this will be equal to, this one will come here and it will be 4. I can take x square common from here. So if I take x square, then this will be x minus 1, positive 4. And if let's say if my x is 2, from here I can go for 2, right? Yeah. So I'll just do the hit and trial method. So in this equation, I'll just write put the value of x as 2. So this will be 2 cube will be 8 minus 1 7, and this will be 2 to the 4 plus 3 7. So yeah, x equal to 2 is an intersection point. So therefore, for the interval of -2 to 2, my y2 will be above. So suppose that this is the graph, and let's say that this is this is y2 and this is y1. Let's say that obviously they are not straight line, but let's say that, so this is -2 and this is 4, and we need to find in this interval, and this is y2 and this is y1. So for the case of -2 to +2, let's say this was the intersection of +2. So in this case, my equation will be y2 minus y1, because the y2 is on the upper side and y1 is on the lower side. And for the case of 2 to 4, my area will be, so for the case of 2 to 4, sorry, this is not, this is y1. Yep. So for the case of +2 to +4, y1 will be on the upper side and y2 will come on the lower side. So for, I can just write, for -2 to 2, area will be y2 minus y1 dx plus, and from 2 to 4, area will be y1 minus y2 dx, obviously. Yep. So I'll substitute the value of this y1 y2 here. So this will become -2 to 2, y2 is x cube minus 3, and y1 is y2 is x square minus 3, sorry, x square minus 3, and y1 is x cube minus 2. This will be minus x cube plus 1, and obviously it will be dx plus integral of 2 to 4, and this will be y1 minus y2, right? So this will be x cube minus 1, and this will be minus x square minus 3 dx. Now I'm going to simplify this. I'll just add this constant. So this will become minus 2 to 2 x square minus x cube minus of 2 dx plus integral of from 2 to 4. This will be x cube minus x square, and this will be minus this was plus 3, I guess. Yeah. So for y2 it was plus 3, right? This should be plus, so plus 3 plus 1, this should be 4. And here we'll get minus 4. And dx. So we'll go for the integration. X square will be x cube over 3 minus x, this will be x power 4 over 4, and this will be 4x minus 2 to 2 plus this will be x power 4 over 4 minus x cube over 3 minus 4x from 2 to 4. Now I will just substitute the values. So this will be 2 cube will be 8 over 3 minus this will be 2 into 2, this will be 2 into 2 into 2 into 2, 4, 2 power 4 or 4 square, 1 4 will be cancelled, so this will be 4, and this will be plus 2 4 is 8 minus this will be minus of 8 over 3, and this will minus power will go on, and this will be minus of again 4, and this will be minus of 8 plus this will be 4 power 4, so 4 into 4 into 4 into 4, 1 4 will cancel, so this will be 4 cube minus 4 cube over 3. Where are my minus plus sign? Oh, yep, so this was minus 4 cube over 3, and this will be 4 for the 16 minus, then here is again this will be 4 minus of 8 over 3, and this will be minus of 4 to the 8. Now I'll just simplify this. So this is this minus minus will become plus, so this will be 16 over 3. This will be minus 4, and this will be plus 4, so this is going to be cancelled. I'm done with this. This will be cancelled, and this will be 8 plus 8 16 plus 4 cube is I think 64. 4 cube and 6. Yup. This will be 64, and this is going to be minus 64 over 3. I think that I have made some mistakes. 3 into 68. This will be 68 minus 40 over 3. 3 times 68 is 204 minus 40. Yep. So this will be 204 minus 40 over 3, and this will be 164 over 3. So let's check the solution given here. The total area of the region is 164 over 3. So yeah, the solution given here is correct. Good work. 7, so this will be 8. Verify the derivative of cosecant x is minus of cosecant cotangent x. This is very easy. We need to find the derivative. So cosecant x is nothing but 1 over sine of x. What I'll do, I'll take the derivative of 1 over sine x. So d dx of 1 over sine x, I'll use the division rule. So that will be 1 sine times differentiation of 1 is 0 minus differentiation of sine x is cosine x, and 1 is multiplied over this will be sine x whole square. This will be 0 and this will be minus cosine x over sine x times 1 over sine x. I can just split this sine x whole square in two terms, so this will become 1 over sine x, so this will become minus of cotangent x, and this will be cosecant x. Cap. Let's just check the solution given here also. So they have also given the same solution. So yeah, so this solution is correct. Good work. Yeah, so that is pretty much all for this session, and if you like this session, then please do hit the like button and subscribe also, and please do hit the bell icon also, so you will be always updated with our next live streams. And this was Devansh, the senior tutor at OneClass. And if you need, yeah, so if you need any tutoring help, or if you want to submit your own questions, then you can check the links in the description below, and I hope to see you soon in my next video. Till then, bye.